GCE June 16 C3 question number 6. Fx is x to the power 4 plus x to the power 3 minus 3x to the power 2 plus 7x to the power 1 minus 6x to the power 0 divided by x square plus x minus 6. Given that this expression is equal to x square plus a plus b over x minus 2, find the values of a and b. My advice for such type of questions is you do the actual division instead of breaking it into the factors. That is easy, and especially the answer is giving in a hint. So let's do the actual division of this. So that is x square plus x plus minus 6. And this is x to the power 4 plus x to the power 3 minus 3x square plus 7x minus 6. This is x square, this is x to the power 4. So we multiplied by x square. X square times x square is x to the power 4. This is x and 2, x to the power 3 and minus 6x square, minus 6x square. Now we have to change the sign, positive negative sign, and this become positive. This cancel, and this will become 6 minus 3. So that is 3x square. This is plus 7x and this minus 6. This is 3x square and this is just x square. So plus 3. So this is 3x square plus 3x minus 18. 6 times 3 is 18. So this will be 3x square and minus 3x square cancel. This is minus and this is plus. So it will be 7 minus 3 is 4x. This is plus 18 minus 6 will be plus 12. So this is equal to fx will be equal to x square plus 3 plus, now we have the remainder is this 4x plus 3. We don't have, if it is a quadratic we would have tried by plus 1, but this is less, so we write it 4x plus 12 divided by x square plus x minus 6. So that is equal to x square plus 3 plus, now 4x plus 12 can be written as 4 common x plus 3, and x square plus x minus 6 is equal to, its factor is x square minus 6. So x square minus, not 3 and 2, minus 3x plus 2x minus 6, x common, x minus 3 plus 2 common, x minus 3. So these factors are 4 x plus 3 and these factors are, is it x plus 3? or is it x minus 3? So why this is a plus, so this should be plus and this is supposed to be minus. So this is plus and this is minus. It should be same, and this will be x plus 3 and x minus 2. So it will be 4 over x minus 2. So plus 4 over x minus 2. This is fx. So a is equal to, a is 3 and b is 4. So that is the answer of this part 1. Part B. Hence or otherwise, using calculus, find an equation to the normal of the normal. Equation of the normal. This is this curve. This is tangent. This is normal. And where x is equal to x is equal to 3 here. So we have to find dy over dx at x is equal to 3. So we have to do two things. For the equation of a normal, y minus y1 is equal to minus dy over dx minus dx over dy x minus x1. Now it's saying x1 is 3 for this equation of this curve. So if x is 3, what will be the value of y? So y will be x square is 3 square plus 3 plus 4 over 3 minus 2. This is 9 plus 3, 12 plus 4, 16. So this value is 16. Now we have to find dy over dx. So this is the equation. Y is equal to x square plus 3 plus 4 x minus 2 is to the power minus 1. So dy over dx, x square is 3 square plus we have to find dy over dx, we are not going to put the value, we have already put the values here. So that is 2x plus 0 plus 4 minus 1 x minus 2 is to the power minus 2. Now at x is equal to 3, so dy over dx will be 2 times 3 is 6 minus 4, this is 3 minus 2 to the power, so it will be a 1. So dy over dx will be just 2. So this value will be so this dy over dx is 2, so dx over dy negative is, so minus half. So the equation of normal will be y minus 16 is equal to minus half x minus 3. So that is the equation. You can just write 2y plus x. This is minus 32. This is minus 32. And this is minus minus plus minus 3. So that is 35. So that is the answer. Gx is equal to arc sine x. Sometimes we call it sine inverse x. X is from, this is 0, this is negative 1 and 1, and y is negative pi over 2. This is pi over 2 to find the graph. You know the sine graph is like this. So this graph will be make sure you draw the proper graph. That is part A. Part B. Find the exact value of x for which 3g x plus 1 plus pi is equal to 0. This is a very good question. Now gx is arc sine x so gx plus 1 will be arc sine x plus 1. So 3 arc sine x plus 1 is equal to minus pi, and arc sine x plus 1 is equal to minus pi over 3. This you take it as it's like this: sine inverse x plus 1 is equal to pi over 3. So I can write this as x plus 1 is equal to sine negative pi over 3, and sine negative pi over 3 is negative root 3 over 2. So x will be negative 1 negative root 3 over 2. Here this step is important. You have to understand this one, and this will be the answer. Question number 8a. Prove that 2 cot 2x plus 10x it will be cot x. You have to prove this one. So let me write it. 2, generally I change all this into sine and cos. Whenever it's cot is there, sec is there, cosec is there, unless there is a direct formula. So this is cos 2x over sine 2x plus sine x over cos x. So this is equal to 2 cos 2x over Sin 2x is 2 sin x cos x plus, I don't have a 2 here, I don't have a sin x here. Now I can write it as 2 sin x cos x and this will be 2 sin square x. Now my denominator is 2 sin x cos x and numerator will be 2 cos 2x is cos square x minus sin square x. Let's take this 2 out, plus sin square x. This 2 cancel, sin and sin cancel. This cos is square cancel, so this is cos x over sin x. So this is equal to cot x. This is what we are supposed to prove. Hence, solve part B. 6 cot 2x plus 3 tan x is equal to cosec square x. Now if I multiply this by 3, so it will be 6 cot 2x plus 3 tan x, so I can write this as 3 cot x is equal to, this is minus 2 also, cosec square x minus 2. I'm going to use the same rule. I convert 3 cos x over sin x minus 1 over sin square x is equal to 2. This is sin square x, so I have to multiply sin and sin here. So this will be 3. So our denominator is sin square x. This is 3 sin x cos x minus 1 is equal to 2. 3 sin x cos x, I can multiply it by 2 and divide by 2. So this will be 3 over 2 sin 2x is equal to 2 sin square x minus 1, and this is cos 2x. Now we divide it. Sin 2x over cos 2x is equal to 2 over 3. So this means tan 2x is equal to 2 over 3. So 2x will be tan inverse 2 over 3. So this is a 0.5880. This is 2x and we have a limit from negative pi x is greater than equal to negative pi and less than pi. But we have 2x, so we multiply all by 2. So 2x is up to negative 2 pi. It means this angle, and positive 2 pi, this angle. And we have 10 here, that is so this values, these two values, a, s, t, and these two values. So we'll be having the 4 values. First we go to the clockwise, so this will be, so x will be 0.5880 and 3.729. 3.729. This is this value and this value. Now anti-clockwise, from 0 to minus 2 pi, we'll be having two value. One is minus 2.5535 and minus 5.695. These are the values of 2x. So the values of x will be, we divide all by 2, and we write up to 3 places of decimals. So the answer will be x is equal to 0.294, 1.8646, then minus 1.2767. 1.2767 is 7, and next is minus 2.8475. 2.8475 is 8. So these are the values of x. 1, 2, 3, 4. These are positive values, and these are negative values. Question number 9. The amount of an antibiotic in the blood stream from a given dose is modeled by the formula x is equal to d e to the power minus 0.2 t. X is the amount of antibiotic in milligrams. D is the dose given in milligrams. And T is the time in hours. A first dose of 14 milligram of antibiotic is given. That is D. Use the model to find the amount of antibiotic in the blood stream after 4 hours. So what it says is, if D is equal to 15 and you have to check it after 4 hours, the amount of antibiotic in blood. So X will be 15 e to the power minus 0.8. So that will be equal to 6.740 milligrams. This was part A. Now part B. A second dose of 15 milligram is given 5 hours after the first dose has been given. Using the same model for this second dose, show that the total amount of the antibiotic in the bloodstream 2 hours after the second dose is given is this. So for such question, don't consider the second dose first. Let's see what is the amount of antibiotic in blood after 7 hours. Because after 5 hours it is given, then after 7 hours. So it will be, so in the first one, say it will be x1, it will be, it was 15 milligrams e to the power minus 0.2 multiply 7 plus, now this medicine is given, this is x2, so this is a second dose of same amount is given, 15 e to the power minus 0.2 show that, so we have to show this is the answer, that is multiply 2. So if you calculate, this will be equal to 13.754. That is part B. Part C. No more doses of antibiotics are given at a time t hours after the second dose is given. The total amount of antibiotic in the bloodstream is 7.5 mg. Now it is saying that after t hours. Here it's saying this is after 7 hours, this is after 2 hours. But now it's saying after t hours, this thing is 7.5. So we are checking, here we were checking after 2 hours and there we were checking after t hours. So let it be t. So this will be t plus 5. So our equation will be 15 e to the power minus 0.2 t plus 5 plus 15 e to the power minus 0.2 t is equal to 7.5. So that is 15 e to the power minus 0.2 t multiply e to the power minus 0.1, 5 times 2 is 10, plus 15 e to the power minus 0.2 t is equal to 7.5. This thing is common, so we can write this as 15 e to the power minus 0.2 t. This is e to the power minus 0.1 plus 1 is equal to 7.5. So e to the power minus 0.2 t is equal to 7.5 over 15 multiply e to the power minus 5 times 2 is 10. This one is 1.0, not 0.1. This is 1.0 minus 1.0, so e to the power minus 1 plus 1. If I take log of both sides, minus 0.2 t is equal to ln 7. I can cancel this by 2. So I can write this one over 2 e to the power minus 1 is 1 over e plus 1. So that is equal to ln, this e will come here, e over 2 e plus 1 so t is equal to 1 over 0.2 negative ln e over 2 e plus 1. So t is equal to, this is minus 5 ln, if I remove minus 5 and put minus 1, so it will be 2e plus 2 over e. So t will be 5 ln 2e over e is 2 plus 2 over e. So a is 5, b is 2 and b is 2. So this is A, this is B, and this is B. And that's the answer. And that's the end of this paper.